Hi guys, welcome back to my channel, and today we will just continue the part 1 of my last video. So today we were going to explore more laws and about exponents. So there is this law that if two expressions with the same base with different exponents, for example a raised to 5 and a raised to 7, when times a raised to 7, if we're going to multiply multiply them, we were just going to add the exponents, right? So we have 5 plus 7, so that's equal to a raised to 12. So the next law would be um, dividing exponents, dividing expressions with the same base with different exponents, like um, 3 a raised to 3 divided by a raised to, yeah, divided by a only. Okay, I'm just going to put one here because there's always an invisible one when you see a base with no exponent. Okay, so the only thing we're gonna do is we're just going to subtract the exponent. So 3 minus 1, that is equal to 2, so it is equal to a raised to 2. Okay, so the other property would be, the other property is that if we have b raised to 5 raised to 2, so all you're gonna do is we just going um, to multiply this. So 5 times 2, so that is equal to b raised to 10. Okay, so we're just going to focus in these three properties. So okay, so let us try to get the concept behind why these laws exist. So in order for you to understand the principle, let us do visualization. Okay, so we know, if we're going to recap, we know that if a is raised to n, that is just equal to a, that's equal to a times a times a, and so forth, and the number of a's would be n times. That's why it's n. So n times. Okay, so I'm just gonna erase this. Yeah, n times. So that should be the thing that we should remember of. So the representation of the exponents here is actually, okay, write this down. I want you to write this down. So the presentation of the exponent here is the number of, okay, the representation of the exponents, okay, yeah, the exponent represents the number of a's. Okay, I'm just gonna a's of the expression, right? Okay, so I'm gonna okay, so I will explain this further. So for example, we have a raised to 2. So sa isip nyo, what is the meaning of a raised to 2? That is just equal to 2 a's just multiplying to each other, right? So a and a, so we have 1 2, so that's why it is 2. Okay, so let's go back to the properties. So let us make some examples here. I'm gonna show it all. Okay, so let us make think we will just make we'll make the examples here. So okay, so let's go to adding exponents. So hmm, let me see. Let's say x cubed times x squared. Okay. So do you wonder why that is just equal to I'm just gonna yeah, same lang yan sa multiply, by the way. Do you wonder why what this is equal to x raised to 5? Okay. So let us try to expand. So let us try to expand these terms. Okay. So we have x. So since it's x cubed, that is x times x times x. And we have x cubed, that is, I mean x squared, that is x times x only. Okay. So the reason why it is equal to x raised to 5, because if we're going to count the number of x, such like this, like 1, 2, 3, 4, 5. So there are 5 x's here. So that's why it is equal to x raised to 5. That is the principle behind this one. Okay. So guys, if you're going to encounter things like this, the core principle behind this laws is this one. Actually, this one. Okay. Okay. So another one. So we are going to. Okay. Let's go to this property. So we have dividing expressions with the same basis and with different exponents. So let's say y squared divided by y. Okay. So let's try to expand. Okay, so let's try to expand this. Okay, so y squared is y times y, right? Then we have, okay, so divided by this one. So y and y. So we have also y here. So obviously we will divide the like terms. So obviously we have like terms here. We have wait, I'm gonna, there you go. So we are going to divide y and y here. So slash it down, because y divided by y, that is equal to 1. And after that, we are going to simplify. So the only remaining term is y. So that's the reason why we need to subtract the exponents, right? So that is just the same as 2 minus 1. And that is y1. Get it? So guys, I just want to show to you the principle or behind this loss. Okay, this one. We will try to explore the principles behind this. Okay. So the next video, this is the part 3, and we will just discover the principle behind this one. Okay, so we have, okay, let us going to use this example. Okay. Okay, do you wonder why b raised to 5 and quantity b raised to 5 raised to 2 is just equal to b raised to 5 times 2 is equal to b raised to 10? Do you wonder why this is the form? I'm gonna explain it to you. So if we're going to expand this, that is just equal to b raised to 5 times b raised to 5. Let's say this is the base and this is the exponent. So that's why I made it in this way. So as always, going back to the principle behind this one, we're going to add. So b, okay, so let us expand this b. So b times b times b, okay, just then expanding it, and we're going to count the number of b's here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many b's? We have 10. So we will put b here and count. We have 10 b's, so it is equal to b raised to 10. And that's the reason why, and this principle is behind this one. The multi the If we just going to multiply the exponents. Okay, so that is for today, and I think I'm gonna explore in the next video about radical expressions. And don't forget to subscribe and like this video, and I hope you understand what I'm talking about in this video, because as a student I will try to to disseminate or to show to you the principles behind the laws of exponents. So see you next time, and enjoy your online class, and wish you a good school and a good online class, and God bless us all. Goodbye.